Hello guys and welcome back. So let's take a look and see why we're getting the same color between the various pieces or different pieces at different locations. And I put this grid and I'm gonna scatter some points on it, and I made an attribute called center ID, and I'm setting it to the point number. And in this case we have 10 points. If we take a look at the point number, it says 0, 1, 2, 3 up until 9. Okay. And then what we're doing is we're doing the point jitter, and then we're using that to fracture the geometry. And I'm going to do the same thing. I'm going to copy cell point to primitives. Okay, and I want to copy the center ID, which we made here, to the points. And let's put down a color node, random from attribute, and it's primitive, so center ID. Cool. So we're getting these colors, and if we take a look at what's happening here is we're getting these points, and then we're creating an attribute that is equal to the ID of these guys. So center ID is equal 7 for this point. Okay. When we do the first fracture, that attribute is copied to this whole piece, and once we start adding the jitter, we're going to transform these points. We're not going to change their ID. We're going to transform them. We're not going to change any of their attributes, in fact, except the position. So if I move them like this, see that number 0.7 is probably now generating a different block, and the center ID value for this piece is the same. Okay, so that point number 7 was used to create this block, which is here, and then was used to create this block, or this block. Let's see, the same color, yeah, something like that. So we're getting the point to be used to Voronoi different blocks at different states, at different positions. Okay, one time we use it with block A, the second time, because it's in a different position, it gets used in a block B. And because the center ID attribute is generated based on the point number, that's not being updated, and we're getting the same value embedded and stored in different pieces multiple times. So what we need to do is we need to generate or update the center ID value every iteration. And the easiest way to do that, if we take a look here, we have 10 points. The easiest way, let's say we start with iteration number 0, and we create the center ID, which equals to from 0 to 10 or 0 to 9. The next iteration, we want to add or offset all the IDs by the total number of points. So the next iteration is going to start from 10 up until 19. The third iteration is going to apply an offset that is equal the total number of points, and that's how we get unique values between the iterations. And we need to implement this in our system. So the first thing that we need to solve if we want to do this is to be able to update the center ID, which is an attribute that is that we're creating here. And the reason I'm using this node or this technique is because I want to get this name to be provided by the user. Okay, and then we're using this local variable here at PT. Now if we want to use the $PT guy inside, we cannot use the $PT or local variables inside a compiled block. We have to do this same operation using vex. Okay, but if we try this with vex, say I want to create an integer test int, okay, and it's equal at ptnum. This is how the syntax looks like. It's the data type, and then the string name or the attribute name, and then the data or the value. Now this is the center ID. This is the text that is coming from the user, okay, from the upper level, which is this guy, the fracture name. We cannot do this in vex. The syntax does not allow us to use an expression here. So we have to do everything in vex, and we're going to use two different expressions. We're going to use one called add point attribute, and then once we create this guy, we're going to set it. So we cannot do both at the same time. And let's take a look at the vex. This is my favorite page, and add point attribute. Add point attribute. We don't want add point, we want add point attrib. Okay, and we know it's a point attribute, so three things: the geo handle, the string name, which is the name of the attribute, and then the default value. So let's remove that and do add point attrib. We're gonna type in 0. The string name is center ID, and I'm gonna hard code this for now to center ID 3, and then we're gonna change it later to be so that it can be provided by the user. The default value is 0, and then semicolon at the end, and we have our attribute. Now you see it's has a value of 0, and that's the default. Now to change this guy, generally we do at, if we know the attribute name, we say center ID 3, and it's equal to at ptnum. Okay, and now we are setting this guy, but we don't know this name. We cannot access this guy this way. So we're going to use the expression called set point attrib. The first thing is the geo handle. The second thing is the attribute name, which is center ID 3. For now it's hard coded. Then the point number, which is at ptnum, that returns the point number every time. And then the value, we want to set it to equal the point value as well. So this is going to be 0, 1, 2, 3, and so on and so forth. And then a third input, which is this a string, we're going to tell it to set this guy. So it's basically the write mode, or what we want to do with this attribute. We want to set it. Okay, so now you see it's changing and working, and we haven't used any of the vex declaration that would make it impossible for us to use an external input. So these two guys are actually strings, and we can simply replace them. So let's do that. Let's add a parameter here, and it's a string, and this is going to be attrib name. I'm gonna call it attrib name, and it's coming from here. It's this guy, and I wanted to channel reference it here so it's easier for me to link. I'm gonna copy parameter. I'm gonna do it here just to get the expression, and I need this guy. And then here I'm gonna say string attrib name, and we're gonna channel reference this guy, which is local here. So this guy now stores the center ID 3, and I'm gonna copy it and paste it here. And this is a local variable, so it's not gonna do anything to the geometry. And let's take a look, and there we go. So now we have everything in vex, and all we have to do is we need to move this guy inside the for each block. Now that it is vex ready, we can use it here. I've already done this, but this is the old version I did. And let's take a look. Everything should work as before, and the values are not unique. I can tell by the colors it's not working yet. So what we need to do is we need to change it now. We need to add an offset. Okay, we need to change the point number or the value of the center ID every iteration, and the way to do that is by multiplying the total number of points by the iteration number. So let's do this. Let's copy the iteration guy, which is coming from here. I'm gonna add a spare input. I will want to import this guy, and let's call this int offset. It's the iteration, but I'm gonna call it offset so we know what the usage, what the use is for. And then I'm gonna multiply the dollar ptnum, the total number of points. Sorry, then the point number by this offset, and then we're gonna multiply. Sorry, we're gonna first add the total number of points, and we can access that using the n points expression. This is going to return the total number of points, and now we're offsetting the number of points with the total number of points, and then we need to multiply it by the offset, so it increments every iteration. Okay, let's make sure it's good. This is good, and let's take a look. And now I can see maybe here it could be coming from the previous one as well, because this fix is only fixing the third level, but the old nodes are not has not been up to date yet. So what I'm going to do is, let's check using the isolation. So let's take a look. Center ID 3. Okay, so it starts, let's say 122. I want to isolate those guys. Okay, so cool. So that's one piece. I need to see one block at a time. We can, and it needs to be contained. Okay, we cannot have this and another piece somewhere here. So let's keep increasing this. Yeah, so that I saw a piece flickering there. Okay, so it's working. Yeah, we're just getting one piece at a time. So this is the fix that we need. And then let me go over this again. We kept the same scatter. This guy, I kept it for the full chain when we do the fracture for the first time, because we're not going to go through this chain. So the old create node works just fine. And then here we're still jittering the point to randomize their position, and then we're changing the center ID attribute every iteration. Okay, so we're offsetting that so it's unique per point per iteration, and that's pretty much it. I'm gonna right click, type properties, hit apply, accept. And I'm gonna say match current definition. Okay, everything is there, cool. And let's do right click, match current definition to update this node as well. Cool. So this guy now should have unique colors as well. I think it does. Yep. And then here and here, yeah, you can see the color is very different between the pieces, so we're good. And there is no neighbors with the same value. So each one of them has a unique value. Cool. So that's the fix, and I want to go over the code again, what we did briefly. And we kept everything, the scatter, the jitter. We are just changing the center ID value, attribute value, and applying an offset so that the number of point is different, or the attribute value for that the value for that attribute is different every iteration for each point. And we're doing that by applying an offset that is equal to the total number of points multiplied by the iteration, and so that keeps incrementing it over and over and over. And I think that's pretty much it. Thank you guys for watching, and see you in the next video. Bye bye.